Hey guys, thanks for joining us again on another science lesson. Today we're going to continue on with our properties of matter unit as we look at what happens to molecules when they change state. What actually happens to the molecules of the material as they change state? Let's take a look at this and see if we can answer that question when we look at the formation of ice.
So I wanted to talk to people about the different states of matter: solid, liquid, and gas, using water as an example. But I thought first I better be sure that we're all on the same page about what water is made of. What's water made of?
Water?
Yeah. What makes water?
Water.
Okay, what elements does it take?
Well guys, don't let this happen to you. If someone comes up to you with a microphone and asks you something like, what is water? Please be ready to answer H2O, a compound.
Water and cold. Water plus cold.
But what does the H and the O mean?
Something in oxygen.
Something in oxygen.
Hydrogen?
There you go.
Hydrogen.
Hydrogen and oxygen. What's the 2 mean?
Hydrogen, oxygen.
And the 2, H2O. Why do we say 2?
I don't know.
It's 2 particles of hydrogen and 1 of oxygen.
There you go. So that makes what we call a water
Compound?
two atoms of hydrogen and 1 atom of oxygen makes a water molecule.
Molecule.
Great job. They said molecule. Now, let's see what happens as we actually take those molecules and cool them down. Let's see what people say.
They're attaching. This is all the guesswork here. I imagine they're attaching to each other.
You
They're
won't need to
forming
guess.
A more solid centerpiece.
You cool liquid water down, and then at some point, what happens to it?
It slows down, freezes, and stops moving.
The molecules become frozen.
How do they become frozen?
They join together. They accumulate. They coagulate.
Coagulate is not the technical term for it, but everyone was on the right track. In ice, the water molecules are basically fixed in place. They form a crystal lattice, where their only motion is vibrating. So what happens if we heat up the ice? What happens when a solid melts?
They all bounce out and
What are we talking about?
melt.
What are they doing?
Well, like in science, you draw little circles.
What are those little circles?
Oxygen.
Are they just oxygen?
Hydrogen, oxygen. And the 2.
And the 2.
The temperature is higher.
So the particles, they're less stable.
Yeah.
Less stable?
Not stable.
More free to move around.
That sounds right.
They become separate and they are allowed to move around. And in gas, maybe they're further apart. Is that what we're okay?
This is
yeah,
fantastic.
That
This
makes
guy's
sense.
nailed it.
All right, that makes sense.
That's
now.
awesome.
All right.
So in liquid water, the water molecules not only vibrate, they can also rotate and slide past each other. And this is what allows the substance to flow. At even higher temperatures, the water molecules become free of that liquid and turn into water vapor. In that state, they are very, very far apart and moving very quickly. So the major differences between solid, liquid, and gas are the motion of the particles and the distance between them.
What's the difference between a solid, liquid, and a gas? I love the answer that he just gave. The distance between the molecules and the speed at which they're moving. And so if you ever get asked by someone wielding a microphone like Veritasium just did, you can answer, it's the distance of the molecules and the speed at which they're moving. That's the real difference between a solid, liquid, and a gas. All right, guys, just make sure you're keeping up to date. You have your superhero project due. It's the 25th, or if you're bringing it to class, please bring it to class before we go to Thanksgiving. And then we have our liquid mountaineering. Look at liquid mountaineering today because it's an interesting idea about when is a liquid more like a solid. So I'm going to show you guys the liquid mountaineering. It's quite an interesting new sport, if you will. I think it's in one of the Scandinavian countries right now, but it could spread. And what I want you guys to do is to take a look at this clip and, of course, some of the resources in the folder. And let's see if we can kind of make sense of what liquid mountaineering is all about.
Few people have tried it. Nobody has ever managed to get anywhere close to what we got like today.
You have to believe you can do these things. It's not like impossible.
There's been a few people that have been sort of following us. It's
me, my boots and we're gonna make it.
I definitely think it's going to be the next big thing. Liquid mountaineering is actually Ulf's brainchild.
It's a new sport. It was not existing before.
You have to run very fast on the water.
I mean, obviously the first step was the most important one. When we discovered, oh my God, Jesus, we're going 1 step, we're going 2 steps, we're going 3 steps. We're discovering it as we go along.
While we're still on land, we try to get up really speed.
Ooh, Gardner.
We touch the water. We try to get like a sewing machine.
It's not straight into the water, you know.
In a curve, in a slight curve.
And by that bend, you're actually not allowing yourself to sink into the water. And you want to
it's like skipping a stone. Like skipping your feet.
Bonjour.
That means hello.
What gets us those extra steps are these shoes. The original equipment where it first all started was the equipment that would help repel water. We found some shoes by mistake, actually. Totally water repellent. It's like water off a duck's back. It takes actually a lot of practice, a lot of focus. I think if you don't actually believe that you're going to walk on that water, it's not going to happen for you.
That time, what went wrong? Here he goes. Well documented, guys. Let's see how many steps are we getting?
We've been working on a jet ski system, obviously that pulls us into the water with a bit more speed.
Be with yourself, believe in it. It's not about the miracle, it's just go for it.
Try to do it. If you fall down, try again.
People want you to think in a certain way, and this sport actually allows you to push your horizons.
Hopefully you guys enjoyed the introduction to liquid mountaineering. Go ahead and go to Schoology, try out the questions, and see where it takes you, because we're going to use the scientific method to look at all the ups and downs, ins and outs of liquid mountaineering. So thanks again for tuning in, guys. We'll see you next time on the next Try in Science.